Okay, this is problem number 6 on section 10.1. So first of all, we need to learn how to set up this calculator in diagnostic on. You need to do this step only once. You don't have to do it every single time. So on the calculator, look, um, you press second 0. This number is 0. Okay. What you will see is this option that says catalog, and then you press. You can actually go all the way down until you find diagnostic on, or you can just get closer by pressing alpha, this key x to negative 1, which is the letter D. Let me do it again, alpha D. So you get closer to this menu it's in alphabetic order. So instead of scrolling down like letter by letter, you get closer to the function we want to access. And then you go down, 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 down until you see the option um, diagnostic on right here. And we press enter. Make sure this pointer is on diagnostic on. Press enter, and then enter again. You should see this screen that says done. So this option is on. Okay. Once you do that, next step is go to stat, number 1 under edit, and set up the table that you're given here. On L1 we have the x values, and then on L2 you have the y values. So let me type these values is 10, 8, 1 second, um, 13, 9, 11, 14, 6, 4, 12, 7, 5. On L2, we type the numbers that are on the y set. So it's 9.13, 8.15, 8.74, 8.78, 8.78, 9.25, 8.11, 6.14, 3.11, 9.13, 7.27, and 4.74. Okay, so once we set up this table, to find the type of scalpel we have is we go to second y equals. You can see the keys I'm pressing here. And then you gotta turn this plot, the plot number 1 is gonna be on. So all you gotta do is press number 1 and highlight on. Just press enter, and you should highlight this. If it is not highlighted, this option, you should highlight it. And after that, we press zoom. It's right here. Number 9 that says zoom stats. Okay, so we actually see this that this is the scalpel corresponding to um, that table. Okay, so it's pretty much looking like this, like option B in my case. And the next part um, is find the linear correlation coefficient R. Okay. Well, to find this this part, the linear correlation coefficient using the T83. We can go to stat. Let me clear this. You go to stat. You choose calculate, and under linear regression, it can be number 4. You press, make sure the x-list is 1 and y-list is 2, and you press calculate. Okay, you will see this number that, let me highlight this. Let me capture this screen. Okay, so you should obtain that number right here. That is the linear correlation coefficient. Okay, now you can see that our number is approximately 0.816. We round it up to 3 small places, which is a little bit different than the correct answer is 0.817 plus minus 0.001. So there is a tolerance here of um, for error. That is good. If you type this number here, it'll be correct. Anyways, the next part on this problem says identify the feature that of the data that would be missed if part B was completed without constructing the scatter plot. Okay, well, let me first of all let me see. Since we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pairs. Okay, so n equals 11. And we have a significance level of 0.05. These are our critical values. Okay, so we have this situation right here. Here, the critical values are negative 0.602 and positive 0.602. Okay, so if R is in this range, we say that there is no linear correlation. And if this value R falls beyond these values, okay, that means linear correlation, either here or here. Okay, so according to this test, I mean, if you compare the R, which is the linear correlation coefficient, with those critical values, we have that there is sufficient evidence to support the claim of a linear correlation between the two variables. Let me write what the null hypothesis is for this test is that rho is equals to 0, and the alternative hypothesis is that the rho is not equal to 0, which is equivalent to say that if rho is equal to 0, that means no linear correlation. And here versus linear correlation. Okay. So when we have that this value R that we obtained previously falls in this zone of linear correlation, we select this option because as I said before, because R is in this region, right? But obviously, the scatter plot shows a relationship that is clearly not linear. Okay, but for that, one of the requirements to conclude linear correlation is that is on page. Let's see, that is on page number 472 of the textbook. Okay. Uh, One of the requirements is that the visual examination of the scatter plot must be confirmed um, that the points approximate a straight line pattern. So this is actually one of the requirements. Okay, that need to actually create a scatter plot, and the visual examination must confirm that the points approximate a straight line pattern. So that's why this part, um, part C, says that if you run the test without the scatter plot, you might conclude incorrectly that there is a sufficient evidence to support the linear relationship. But the scatter plot actually tells you that the relationship is not linear. There is no straight line pattern. Okay? So you can find these requirements on this page of the textbook for page 472.